Alright, so we're moving on to section 7.3, which is solving exponential equations with the same bases. Let's start by looking at how to get these bases the same. So our goal is that if we're solving an exponential equation, we can use the property that if the bases on either side of an exponential equation are equal, so again, bases have to be equal, then the exponents must also be equal. So what I'm saying, you guys, is if you have 4 squared, that would be equal to 4 squared. So if the bases are the same, then their exponents would also have to be the same if you have an equal sign in between them. So what we have to do is get these things to the same base by simplifying before we can solve. So first, what I'm doing here is I'm not solving anything. We're just going to practice rewriting them with a base of 3. So we're going to break this down so that it has a base of 3. So 27, 3 to what power gives us 27? 3. Good. Let's look at a trickier one.
3 to 4.
Let's just look at 9. 9 is 3 squared. And then there's that extra squared in the original question. So when we calculate it, we go the 2 times the 2, which gives us 3 to the power of 4. So again, any of these functions we should be able to get into a base of 3. C looks quite a bit more complicated. Let's take it one step at a time. First of all, 27. We already said 27 is 3 to the power of 3. And that 27 was to the power of 1/3. So far I've got 3 cubed to the power of 1/3. Now let's look at the next one. 81. What's that 3 to the power of?
3 to the power of 4.
3 to the power of 4, good. And notice here how I have a root. Remember that we said a root is actually a fraction exponent? So this would be, the 3 would be the denominator, so 2 over 3 would be my fraction. So now we have a power to a power, so we multiply. So 3 times 1/3, I'm going to write it as 3/3. You could write it as 1, but I see something coming in the next one where there's also a 3 in the denominator, so I'm just going to keep it as 3/3 for now. Here we have 4 to the times 2/3, so that'll be 3 to the power of 8/3, because 4 times 2 is 8, and then the 1 times the 3 is the 3. So here we have 3 to the power of 3/3 times 3 to the power of 8/3. When you have two things multiplied together, what do you do to your exponents? Add them. So now we're going to go 3 to the power of 3/3 plus 8/3 to get 11/3. If you're forgetting your exponent laws from Math 9, you can go through this slide quickly, and then there's some examples here that follow. So again, these are just the exponent laws from grade 9. So our example says solve 9 to the power of 4x equals 27 to the power of x minus 1. The goal when we're solving these is to get them into the same base. So what can both 9 and 7 be broken down to for a base? 3. Good. So what I'm trying to get these to is a base of 3. So 9 I know is 3 squared, and that would be to the power of 4x. 27 I know is 3 cubed, and that would be to the power of x minus 1. So we're starting by getting them to the same base. Then we have to use our exponent laws to simplify. So on this side, I have a power of 2 to a power of 4x, so we have to multiply. So 2 times 4x is 8x. Now on this side, I have a power of 3 times the power of x minus 1. Be careful, that is a binomial, so the 3 is going to have to get multiplied to both pieces. So we'll get 3 to the power of 3x minus 3. Again, the 3 is going to get multiplied to both pieces of the binomial. Now we're pretty much done, you guys. The rule said that when you have bases that are equal, then the exponents must also be equal. So I can now just look at my exponents, and I'm going to set 8x equal to 3x minus 3. Again, my bases are the same. So now I can say that my exponents are also equal.
So do we have to divide 8 over?
So we'll move our 3x over here to be with our 8x. So we're left with 5x equals 3. And then when we divide out that 5, we're going to get x equals 3/5 for our answer. So again, this means that x in our exponent is 3/5. I did forget the negative, thank you. It is a minus 3 right here, so that'd be a minus 3/5. once you go through the U try, you should get answers of 1 and 4.5. So try the U try and then compare your answers with those on the board. Alright, so the other option after you have tried solving by getting equal bases, the other thing that might happen is maybe the bases can't be made the same. So if the bases can't be made the same, you have to use another method to solve. You could guess and check, but guess and check would be very tedious. The other method is graphing. So what we would do is we would switch over to Desmos and graph this, each side separately, to find where they cross. Alright, so when we go to Desmos, we type both sides in separately. So we go 10 to the power of x, and then y equals 0.5, since that was the other side. And all we're looking for here is where these two cross. So they cross at an x value of negative 0.301. So, again, all I'm looking at here is my two sides graphed separately. The x value where they cross is my answer. So we would go back to the board and we'd write that x equals negative 0.30.
That's your y value.
Alright, in our final example here, we should be able to then use word problems along with the solving methods that we had in order to actually solve a word problem. So remember that we've discussed that the A value is our starting amount. So here we have a mouse population starts at 25,000. It's decreasing at a rate of 20% every 2 years. That part's very important. What will the population be after 3 years? So let's start with our base. What's the base of this? 0.8. Right. Because, hang on, because it's 20%, so it decreases from 100% down to 80%. Now the 25,000 is what we start with, so that's going to go in our A spot. This is the tricky part. It says every 2 years. Years is my x-axis. So my x-axis would normally be in 1 year increments, but I'm going to be stretching the x-axis so it's at 2 year increments. So my b value is going to be 1 over 2x. Good. Now if we look at what this means, remember that the y value and the a value are the same units. So 25,000 is mice, so that means y is talking about mice, and then x would be talking about years. So if we want to solve this, it says what will the population be after 3 years? I'm going to be plugging in 3 in for x. So all we would do is go 0.8 to the power of 1/2 times 3, which is really to the power of 1.5. 0.8 to the power of 1.5, because half times 3 is 1.5. So let's calculate that using our calculators. So our population there would be 17,889 mice.